Right, so let's gather our eyes up this way so that we can see what's going on. We've talked about two things on our previous time together, and what we chatted about was this idea of a transformation called a translation. And what we did, a translation means don't change the shape of the graph at all. All you do is shift it. So for example, if you have a U-shaped graph, and you just move it over to the right 4 or 5 or 6, then all you're doing is called translating it horizontally. But we could also shift it down or up, and we could also do both at the same time. So when we're thinking about this, you might want to think about translations as an Etch-a-Sketch with 2 knobs, telling you where to move the entire thing with no changes. Now, what we're going to chat about today are called also transformations. We change the form of it. So we're not just changing the location, but we're going to change the actual shape in some way, or the orientation of the shape. So a reflection flips the graph of a function across a line. So if we look at the first one here, we have this axis right there. So what we're doing is taking this point right here and just reflecting it across. Now this one here reflects across there. The top reflects here. The way on the right reflects, so now it's way on the left. So notice it's essentially the same shape. Again, it's just orientated differently. Now the same thing applies to flipping it on the y-axis. Is, again, this one is closest to the y, or the x-axis, so this one's closest to the x-axis there, etc. This one's farthest, so this one's now farthest. So we flipped it upside down. So we're not doing any rotating. We're not doing this. That would be a different thing. What we're doing is just flipping in some manner. All right. Notice the key here is that everything is the same distance from the line, but it's just on the other side of it. Okay? When you reflect a graph on the y-axis, the x value changes signs, and the y value stays the same. Now, what does that mean? Notice over here, the 5 is still 5, 5 is still 5, but the 1 becomes negative. Up here, the 3, 4. The 3 stays 3, but the 4 becomes negative 4. So only make the 1 change on the y. So again, it's kind of like the opposite. You want to reflect on the y-axis, you have to change the x, and the same thing is true. If you want to reflect on the x-axis, you have to make a change in the y. So we just talked about making the change in the y. Over here, if I have a 1 up here, so this one's still up 1 there, but I just changed the x value there. All right. So how do we interpret this right here? So our function is called f of x. The reflection in the y-axis is we just take the x and make it negative. That'll make some other changes. And here, if we just make it negative of the whole thing, it reflects it along the blue line, like I put the mirror flat on the ground and it flips upside down. All right, so let's think about this one here. Let h of x, remember these are just names of functions, h of x be the reflection of f of x, 3x plus 3 in the x-axis. In the x-axis. So I go back up, and if I want to reflect in the x-axis, what do I do to my function? Where do I put the negative? So putting the outside like so. Next, now we're going to write the function rule for h of x. Then we're going to graph h of x and f of x. So this gets a little bit ugly. So here's f of x, right? So f of x is here, so I'm going to start there, which is f of x equals 3x plus 3. So if I want to reflect it, where do I put the negative? I have to put the negative in the front. So if I put the negative in the front like this, then I have to put it in the front over here as well. Notice I'm going to group the whole thing and put the negative in the front. So what do I do with that negative on the right side? What do I do with this negative on the right side? I just distribute it. Now we already know that this right here is called h of x, so I'm going to change that. Instead of calling it the opposite of f of x, I'm just going to call it h of x. And now I can distribute, and this is my function rule. And that's it. So I put a negative outside and simplified if I could. So in this case, the only simplification was distributing. Sometimes a simplifying would be moving the x around or something like that. All right, so number 1, it says, write the function rule for x, h of x. So I did that. Next, I'm going to graph h of x and f of x to check the reflection. So I'm going to graph the f of x with the blue, and remember how to interpret this. This tells me where to begin. This tells me how to move. So I do start on the y being 3. Up 3, right 1 from the original 3. Just a coincidence that I have 3's there. Now it looks like I'm going to go off the chart here. So instead of going up and right, I'm going to go down 1, 2, 3, and right 1 to put it there. Again, I could have gone the other way, up 1, 2, and 3 to be off the chart like that. And I'm going to connect the dots there. Now we begin at negative 3 for h of x. And now we go down 3, right 1, 1, 2, 3, I'm off right here. Or I go up 1, 2, 3, right 1 here. So coincidentally, left. Sorry, yeah, left. Up and left or down and right. So how does this mean it reflected? What did it reflect off? It reflected off this line. And how do I know? Because it's on the axis for both of them. This one here is above the axis 3. This one's below the axis 3. This one here at 1 is above the axis 6. This one's below the axis 6. So I see that it is a reflection. Turns out my reflections cross, and that's not always the case, but in this case it is. Let's look here now. Our last thing we're going to talk about is how do we stretch it or compress it. We squash it down or stretch it out. What kinds of things happen? So for a function f of x in the table below, what are the corresponding table and graph for the transformation h of x equals 1/3. So notice I have a number in the front, which means I am going to either compress it, shrink it down, or I'm going to stretch it out. So let's see what does happen here. So let's just make our graph and see what happens. Whatever number I got out right here, I just multiply it by 1/3. So in this case, if you divide this one by 3, then I get 2/3. If I divide this one by 3, because 1/3 is the same as dividing by 3, I get negative 1. Now if I divide this by 3, I get 1/3, and divide this by 3 to get negative 2/3. So now when I graph these, I'm effectively temporarily ignoring this column because that one's already graphed. What I'm going to graph is a negative 5 and a 2/3. So let's see what happens there. So negative 5 and 2/3 is approximately right there, right underneath the 1. Then a negative 2 as a 2/3, which is what I expected. I expected parallel lines, so notice so far it is. And I can connect those dots there. At 0, I get negative 1. So at 0, I get negative 1, which is right there. So I can connect that. At 3, I get 1/3, which is somewhere about there. And then at 5, I get negative 2/3, which is almost to the next line under. So notice what I've done. All we've done is taken the whole thing and squashed it. We just take this and squash it together. And that's what the 1/3 means. Just squish it. Vertical squishing. That's what happened here.